let's get started on this homework assignment. So the first problem is to calculate the average rate of change of a function over the given interval. So we need to take f of 0. Oh, this is horrible. F of 0 minus f of 3 over 0 minus 3. So when we do that, f of 0 is going to be 0 squared minus 0 plus 1 minus 3 squared minus 3 plus 1 all over negative 3. So that gives us 0 minus 0 is 0 plus 1 is 1 minus 3 squared is 9. Negative 3 plus 1 is negative 2. And that's over negative 3. Then we have 1 minus 7, which will give us a negative 6 over negative 3, which is 2. Over here, number 2, we will have f of negative 3 minus f of negative 2 over negative 3 minus negative 2. So when we go to solve that out, we have negative 1 over x minus 2. Oh, sorry, I don't know why I've said x. Negative 1 over negative 3 minus 2 minus negative 1 over negative 2 minus 2. All over negative 3 minus negative 2 is negative 1. So when we solve all of that out, we can divide out this negative. Well, actually, I'm just going to simplify my top fractions first. I have a negative 1 over negative 5 minus negative 1 over negative 4. And again, that's all over negative 1. So I'm going to go ahead and give them common denominators here. We can multiply, let me change my ink here. We can multiply this one by 4 over 4, multiply this one by 5 over 5, and we will get a negative makes a positive, so 4 over 20 minus 5 over 20. Again, that negative made a positive. And divided by negative 1. So negative 4 minus 5 will be negative 1 over 20. Negative 1 over 20 divided by negative 1 will just be 1 over 20. I just filmed this whole thing and realized I wasn't recording at all. So let's go and do this again. So much fun! So when we're calculating this, remember we want to do f of negative 2 minus f of negative 3 halves all over negative 2 minus negative 3 halves. Remember, rate of change is the same thing as slope. When I start dealing with fractions, I like to first deal with my numerator, then my denominator. So here, if we look at our numerator, we're going to have negative 2 squared plus 2, that's our f of negative 2, minus negative 3 over 2 squared plus 2, and that's going to be my f of negative 3 halves. So let's go ahead and solve that out. Negative 2 squared is 4 plus 2 minus negative 3 over 2 squared will be 9 over 4 plus 2. In order to add those, I'm going to need common denominator, so this can be a 6 minus, we'll have 9 over 4 plus 8 over 4. Looking ahead of time, I know I'm going to need common denominator, so might as well change that 6 now. 24 over 4 minus 17 over 4, and that is going to give me 7 over 4 for my numerator. Now let's go and let's take care of our denominator. And some of you may like solving it all out at the same time. That's fine. I just confuse myself easily, so I try to keep it nice and organized. Again, we're going to need some common denominators here, so that'll be a negative 4 over 2 minus negative 3 over 2. That will be a negative 1 over 2. We'll go ahead and put those together. That's 7 over 4 divided by negative 1 over 2. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So we end up with negative 14 over 4, which is negative 7 over 2. Our next problem, again, it is going to be f of negative 1 minus f of negative 1/2 all over negative 1 minus negative 1/2. Again, when we work that out, I'm going to break it up into my numerator and my denominator. So in my numerator, I will have 2 times negative 1 squared minus 2 times negative 1 plus 1 minus, that was my f of negative 1. Now my f of negative 1/2, 2 times negative 1/2 squared minus 2 times negative 1/2 plus 1. Let's solve all that out. Negative 1 squared will be positive 1, 2 times positive 1. Negative 2 times negative 1 will be a positive 2 plus 1 minus 2 times negative 1/2 squared will be positive 1/4. Negative 2 times negative 1/2 will be a positive 1 plus 1. Let's keep on going. 2 times 1 is 2, plus 2 is 4, plus 1 is 5. Minus 2 times 1/4 will be 2/4 or 1/2. 1 plus 1 is 2. So we have 1/2 plus 2, that's 2.5. 5 minus 2.5 is going to equal 2.5. Since we're dealing in fractions, I'm going to put it as a fraction. 2.5 is 5 over 2. That's in our numerator. Now let's check out our denominator. In our denominator, we have negative 1 minus negative 1/2. That is going to be a negative 1/2. Let's put those two pieces together. 5/2 divided by negative 1/2. Remember, dividing by a fraction is the same as multiplying by the reciprocal. And so we get negative 10 over 2, which is negative 5. Rate of change again, we'll do f of negative 1 minus f of negative 1/2 over negative 1 minus negative 1/2. Going through, again, I'm going to separate into my numerator and denominator, especially since we're dealing with fractions with fractions. Numerator. In our numerator, we will have f of negative 1, which is negative 1 over negative 1 plus 2, minus f of negative 1/2, which is negative 1 over negative 1/2 plus 2. Solving that out, we have negative 1 over 1 minus negative 1 over 1.5. But I'm going to write 1.5 as a fraction, which would be 3 over 2. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So we have negative 1 minus negative 2/3. Negative 1 minus negative 2/3 will be negative 1/3. And then we'll check out our denominator. In our denominator, we have negative 1 minus negative 1/2, which will give us negative 1/2. Putting all of that together, numerator, negative 1/3 over denominator, negative 1/2, Remember, dividing by a fraction is the same as multiplying by the reciprocal. And so we have negative negative makes a positive 2/3. And our last and final rate of change problem. Again, we will have f of 0 minus f of 1/2 all over 0 minus 1/2. When I deal with fractions, I'm going to break it up since we have a fraction in our range. I was about to put numeration. That's not a word. But in our numerator, we will have f of 0, which is 2 times 0 squared, plus 0 plus 2, minus f of 1/2, which will be 2 times 1/2 squared, plus 1/2 plus 2. Solving that out, we get 0 plus 0 plus 2, which is just 2, minus 2 times 1/2 squared is 1/4, and then 1/2 plus 2 is going to be 5/2. Go ahead and keep solving this baby out. We will get 2 minus 2 times 1/4 is 2/4, which is 1/2, plus 5/2, which is 6/2, or 3. 2 minus 3 is -1. Now let's check out our denominator. In our denominator, we have 0 minus 1/2, which is -1/2. So when we put those together, we have our -1 divided by our -1/2. Remember, dividing by a fraction is the same as multiplying by the reciprocal. Negative times a negative is positive 2. Definition of derivative. Remember, the definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's go ahead and do that. When we remember that x plus h, it's just like if we said f of 3, we would plug in 3 for x. With f of x plus h, we'll plug in x plus h for x. So we will have -2 times x plus h plus 5. Right there, that is f of x plus h. Minus f of x, which is -2x plus 5, all over h. And remember, we're taking the limit as h approaches 0, but I just really don't have space to write that. So let's multiply this out. -2x minus 2h plus 5 plus 2x minus 5 all over h. Our -2x and +2x cancel out. Our 5 and -5 cancel out. We have -2h over h, which is just -2. So what is the limit as h approaches 0 of -2? Well, that's just -2. Now let's do the next one. We have f of x plus h, so that'll be -4 times x plus h minus 2 minus f of x, which is our -4x minus 2 all over h. Let's go ahead and do some multiplying out. That's -4x minus 4h minus 2 plus 4x plus 2 all over h. Do some combining here. -4x and +4x will cancel out. -2 and +2 cancel out, and we get -4h over h. Those will cancel. That equals -4. So what is the limit as h approaches 0 of -4? Well, that's just -4 at this point. So let's remember that this is the limit as h approaches 0 of f of x plus h minus f of x all over h. So 4 of x plus h squared plus 1 minus 4x squared plus 1 all over h. We're going to have to do some multiplying binomials here, or foiling, and we'll get x squared plus 2xh plus h squared plus 1. And then we'll distribute out that negative, minus 4x squared minus 1. Now let's multiply, and that's all over h. Let's distribute out that 4x squared plus 8hx plus 4h squared plus 1 minus 4x squared minus 1 all over h. We'll simplify some. We have a positive 4x squared and a negative 4x squared. Positive 1 and negative 1. We're left with 8xh plus 4h squared over h. We can factor out the top to be h times 8x plus 4h all over h. Those will cancel, and we have the limit as h approaches 0 of 8x plus 4h. We don't have any domain restrictions here, so we can just plug in 0 for h, and we will get 8x. That is our derivative of this function. I erased some of the work to give me a little more room for this number 4. So for number 4, we have negative 3x plus h squared plus 4 minus negative 3x squared plus 4 all over h. I think I put an extra parenthesis in there at the end, but that's okay. So we'll do some multiplying of the binomial, and when we do that, we get negative 3 times x squared plus 2xh plus h squared plus 4. Negative 3 will be a positive 3x squared, negative, and positive makes a negative 4, or minus 4, all over h. We'll distribute out that negative 3 now, and we get negative 3x squared minus 6xh minus 3h squared plus 4 plus 3x squared minus 4 all over h. Do some simplifying. Negative 3x squared and positive 3x squared will cancel out. Positive 4 and negative 4 will cancel out. And we have negative 6hx minus 3h squared all over h. We can factor out that h at the top. We'll get h times negative 6x minus 3h over h. Our h's will cancel, and we're left with the limit as h approaches 0 of negative 6x minus 3h. We have no domain errors in there, so we can just plug in 0 for h, and we get that the limit equals negative 6x. Alright, here we go again. It is the limit as h approaches 0 of f of x plus h minus f of x all over h. So solving this one out, we will have negative 4 times x plus h minus squared minus 5 times x plus h minus 2. And that is all minus the function itself, negative 4x squared minus 5x minus 2 all over h. Whew, we have a lot of work to do here. That's negative 4 times x squared plus 2xh plus h squared minus 5x minus 5h minus 2. And then negative will make a plus 4x squared plus 5x plus 2 all over h. Don't give up, keep on going. Negative 4x squared minus 8xh minus 4h squared minus 5x minus 5h minus 2 plus 4x squared plus 5x plus 2 all over h. Let's do some fruit ninja here. Negative 4x squared, positive 4x squared. Negative 5x, positive 5x. Negative 2, positive 2. And we have negative 8xh minus 4h squared minus 5h all over h. We can factor out that h on the top. H times negative 8x minus 4h minus 5 all over h. And when we do that, our h's will cancel, and we get the limit as h approaches 0 of negative 8x minus 4h minus 5. We have no domain restrictions there, so we can just plug in 0 for h, and we will be left with negative 8x minus 5. Again, like I told you, when I'm trying to memorize something, I rewrite it over and over and over again. The limit as h approaches 0 of f of x plus h minus f of x all over h. So, plugging all that in, we have 3 times x plus h squared plus 3 times x plus h plus 3 minus our regular f of x, which is just 3x squared plus 3x plus 3 all over h. Now we have 3 times x squared plus 2xh plus h squared plus 3x plus 3h plus 3. I just simplified that up as much as I could. Minus 3x squared. We're going to distribute this negative out. Minus 3x minus 3 all over h. Now I'm going to go ahead and distribute that 3. Oops, one too many times there. Whoop. And we get 3x squared plus 6xh plus 3h squared plus 3x plus 3h plus 3 minus 3x squared minus 3x minus 3 all over h. Doesn't that just look beautiful, you guys? Let's do some canceling out. 3x squared minus 3x squared, 3x minus 3x, 3 minus 3, and we end up with 6xh plus 3h squared plus 3h all over h. We can factor out our h at the top. That'll be 6x plus 3h plus 3. Our h's cancel out, and our final answer will be the limit as h approaches 0 of 6x plus 3h plus 3. We have no domain restrictions here, so we can just plug in 0 for h, and we will be left with 6x plus 3. That is our derivative at this point. Here we go. The limit as h approaches 0 of f of x plus h minus f of x, goodness gracious, the stylus, all over h. So we will have the square root of negative 3 times x plus h minus 5 minus the square root of negative 3x minus 5 all over h. So let's go ahead and we'll simplify the inside of the one that we can. We will get negative 3x minus 3h minus 5 minus the square root of negative 3x minus 5 all over h. Now, what did I tell you you are always going to do whenever you have square roots and a plus or minus? Oh, Miss Dees, we're going to multiply by the conjugate. So we're going to multiply by, I don't have enough space to write this. Maybe I'll write it sideways. We are going to multiply by the square root of negative 3x minus 3h minus 5 plus the square root of negative 3x minus 5 all over the square root of negative 3x minus 3h minus 5 plus the square root of negative 3x minus 5. Slanty doodle. When we do that, everything in our square roots will cancel out because remember we will FOIL and our outer and inner terms will cancel out. We get negative 3x minus 3h minus 5 minus negative 3x minus 5. And that will be over h times the square root of negative 3x minus 3h minus 5 plus the square root of negative 3x minus 5. I'm going to run out of room on this slide, I already know. So let's just keep on working. Negative 3x minus 3h minus 5 plus 3x plus 5 all over h times the square root of negative 3x minus 3h minus 5 plus the square root of negative 3x minus 5. All right. Pause it, write this down if you haven't yet. We're going to move on to another slide. This is where we left off on the last slide. So let's go ahead and finish it out. We can fruit ninja. We have negative 3x positive 3x, negative 5 positive 5. So our equation now becomes negative 3h over h times the square root of negative 3x minus 3h minus 5 plus the square root of negative 3x minus 5. Our h's will cancel out, and our equation becomes the limit as h approaches 0 of negative 3 over the square root of, that's too big of a square root symbol, the square root of negative 3x minus 3h minus 5 plus the square root of negative 3x minus 5. So we have no domain restrictions that will come up when we plug in a 0 for h. So we end up with negative 3 over the square root of negative 3x. Negative 3 times 0 will be 0. So minus 5 plus square root of negative 3x minus 5. We can write that in a more simple form. 2 times the square root of negative 3x minus 5. Woohoo! Wasn't that fun? Didn't you love that? Now we get to do it all again. Remember, we're still doing the limit as h approaches 0 of f of x plus h minus f of x. If you're tired yet, please go on a walk, go feed your dog, go get a cup of hot cocoa and sit by the fire and pretend it's fall so that maybe fall will come already. Try not to die of heat stroke though. So let's go. Red, bad color. We'll do a dark red. We have the square root of 4 times x plus h minus 5 minus the square root of 4x minus 5 all over h. I'm not even going to bother with distributing out that 4 yet. I'm just going to go ahead and multiply by the conjugate right away. So we'll multiply by 4x plus h minus 5 plus 4x minus 5 all over the square root of 4x plus h minus 5 plus the square root of 4x minus 5. And we'll multiply this out, the first terms, the last terms. Remember, our outer and inner terms, since they're opposites, will end up canceling out. And so our outer and inner terms will cancel, and we will just be left with 4x plus h minus 5 minus 4x minus 5. And it's all over our crazy denominator here, the square root, h times the square root of 4x plus h minus 5 plus the square root of 4x minus 5. And we will go ahead and simplify our denominator. I'm just going to kind of do that off to the side if that's okay with you guys. I'll get 4x plus 4h minus 5 minus 4x plus 5 when we distribute out that negative. And that will simplify down 4x, negative 5 and 5 will cancel out. And we now have 4h over h times the square root of 4x plus h minus 5 plus the square root of 4x minus 5. Our h's will cancel out. And we are left with the limit as h approaches 0 of 4 over the square root of 4x plus h minus 5 plus the square root of 4x minus 5. There are no domain errors when we plug in 0 for x. So I'm going to bring this over here. Our answer will end up being 4 over the square root of 4x minus 5 plus the square root of 4x minus 5. Or we can simplify that down to be 4 over 2 times the square root of 4x minus 5. The 2 and the 4 will reduce, and we will get 2 over the square root of 4x minus 5. Alright, now remember we're still doing the limit as h approaches 0 of f of x plus h minus f of x all over 8. So, to start off, we're going to have 1 over x plus h plus 2 minus 1 over x plus 2 all over h. Now, I don't like having it over h, so I'm going to go ahead and I'll rewrite this. This is like 1 over x plus h plus 2 minus 1 over x plus 2 times 1 over h. So first, let's deal with the inside of the parentheses here. I'm going to give them common denominators simply by multiplying each denominator by the other. When we do that, we will have x plus 2 minus x plus h plus 2 all over x plus h plus 2 times x plus 2. And again, this is all still times that 1 over h. Do some simplifying, and we'll have x plus 2 minus x minus h minus 2 over x plus h plus 2 times x plus 2 all times 1 over h. Do some simplifying here. X, 2, negative 2. And we have negative h over x plus h plus 2 times x plus 2 times 1 over h. Our h's will cancel out. And we have now the limit as h approaches 0 of negative 1 over x plus h plus 2 times x plus 2. We have no domain errors when we plug in 0 for h, so we have negative 1 over x plus 2 times x plus 2, or a more proper way to write it, negative 1 over x plus 2 squared. Alright, I'm having so much fun. What about you? Let's remember we're doing the limit as h approaches 0 of f of x plus 1 minus f of x all over h. So we're going to go ahead and plug all that in. We have negative 2 over 2 times x plus h minus 1 minus negative 2 over 2x minus 1, and it's all going to be over h, but remember over h is the same as times 1 over h. So I'm going to go ahead and write it this way. I need to give these babies common denominators, so I will multiply by the denominator of the other. And then this will be times 2x plus h minus 1 and times 2x plus h minus 1. When we do that, we have negative 2 times 2x minus 1 minus negative 2 times 2 times x plus h minus 1. And that is all over 2 times x plus h minus 1 times 2x minus 1. Whew, we have a lot of simplifying to do, and please remember that this is times that 1 over h. We can't forget that. And as we're going, we will first distribute this baby out. We have negative 4x plus 4 minus, we have a lot of work to do inside here before we can actually do much. This is going to be 2x plus 2h once we distribute this part. Then we need to take this negative 2 and distribute it out to everything. So we'll have minus a 4x, and we'll have a negative 4h, and then we'll have a positive 2. And this is all over our 2x plus h. I just caught a mistake. Sorry. Something was wrong in the math force. I've been doing too much. Need to take a break. Maybe you need to take a break. Don't be afraid to. This should be 4x plus 2. So when we go ahead and distribute out in our numerator, I'm going to simplify this off to the side again. We're going to get negative 4x plus 2 plus 4x plus 4h minus 2. So we have a negative 4x, positive 2, negative 2. So we have 4h over 2 times x plus h minus 1 times 2x minus 1, and that's still times that 1 over h, so these cancel out. Our final answer is going to be the limit as h approaches 0 of 4 over 2x plus h minus 1 times 2x minus 1. There's no domain errors when we plug a 0 in. So we have 4 over 2x minus 1 times 2x minus 1 and we can write that as 4 over 2x minus 1 squared. Find the slope of the function at the given value. Write a line tangent and normal to the function. Yes, these are kind of long problems, but you can do it. So remember, we're looking at the limit as h approaches 0 of f of x plus h minus f of x all over h. So we have x plus h squared plus 6x plus h plus 7 minus x squared plus 6x plus 7, and that is all over h. Working that out, we will get x squared plus 2xh plus h squared. We'll distribute the 6 plus 6x plus 6h plus 7. Then we'll distribute this negative through. Negative x squared minus 6x minus 7 all over h. Doing some simplifying, we have a 6x squared and a negative x squared. We have a 6x and a negative 6x, and we have a 7 and a negative 7. So we are left with, oh, you know what I realized? This should be an h again. I'm sorry, you guys. I'm going to pause this, go get some dinner. Maybe you should do the same. Plus h squared plus 6h all over h. We can factor out that h. That's h times 2x plus h plus 6 all over h. When we take the limit as h approaches 0 of 2x plus h plus 6, we simply get 2x plus 6. This is our derivative. Now it wants to know at the point negative 2. So when we plug in negative 2, our slope of the line is going to be 2 times negative 2 plus 6. That's negative 4 plus 6, which is 2. When we write our two equations, I'll use color red. Our line tangent will be y. Oh, whoops, sorry. We need to find our y value because I don't know what y1 is. So we will take negative 2 and plug it in up here. Negative 2 squared plus 6 times negative 2 plus 7. That's 4 minus 12 plus 7. That's negative 8 plus 7, which is negative 1. So y plus 1 equals 2x plus 2. And then our line normal, remember normal is opposite reciprocal, y plus 1 equals negative 1/2 x plus 2. Alright, so here we go. We have x plus h cubed minus 3 times x plus h squared plus 5 minus x cubed minus 3x squared plus 5. First thing we need to do is figure out x cubed. So we are going to have x squared plus 2xh plus h squared. That's x plus h squared, right? Times x plus h. I still like using Punnett squares. If you guys don't, then you solve for cubes however you do that. So x squared h, then we have 2x squared h, and then we have h squared x, then we have 2xh squared, and then we have h cubed. So my x plus h cubed becomes x cubed plus 3xh squared, or x squared h, sorry, plus 3 h squared x's plus h cubed And this is going to be then minus 3 times x squared plus 2xh plus h squared, then plus 5, and then we have our minus, I'm out of room, minus all of that stuff there. So we still got quite a bit more of simplifying to do, obviously, and remember this is all over h. So we have x cubed plus 3x squared h plus 3h squared x plus h cubed minus, we're going to have 3x squared minus 6x h minus 3h squared minus x cubed plus 3x squared minus 5. Woo! All over h. So beautiful. So beautiful. So let's cancel some stuff out. X cubed, negative x cubed. Negative 3x squared, 3x squared. We should have a positive 5 in here somewhere. I dropped it out. Where did I drop it out at? That should be right here. There should be a positive 5 there. Sorry. Positive 5 and negative 5 cancel out. 3h and negative 3h squared cancel out. Looks like that's all that cancels out. So we have 3x squared h plus h cubed minus 6xh all over h. This can factor out to be h times 3x squared plus h squared minus 6x all over h. Those will cancel, and we have the limit as h approaches 0 of 3x squared plus h squared minus 6x. There's no domain errors when we plug in 0, so we get 3x squared minus 6x. That is our slope. Follow me on to the next slide to find the normal and tangent line. So at the end we ended with the derivative of 3x squared minus 6x at x equals 3. So we'll plug in 3 for x. And so we get 27 minus 18, which equals 9. Now we need to figure out what the function equals at the point 3. Our function was x cubed minus 5x squared. I'm so sorry. I'm trying to look at a small little thingy here. Minus 3x squared. And then I think it was a plus 5. So we will plug in 3 for all of those. F of 3 equals 3 cubed minus 3 times 3 squared plus 5. That equals 27 minus 27 plus 5, which is just 5. So our point is 3, 5. When we're looking at the line tangent, we will have y minus 5 equals our slope 9, x minus 3. And when we're looking at our line normal, we'll have y minus 5 equals negative 1/9 x minus 3. So you may hate me, but for the length of this video, I'm not going to be able to fully work out these problems, but I will tell you what their derivatives are. The derivative of number 3 is 3x squared minus 12x plus 9. That's what you should have gotten for the derivative. Then you'll plug this in to get your slope, and then plug that also into the original equation to figure out your y value and find your normal and tangent lines. On number 4, our derivative is negative 3x squared minus 12x minus 9. And then you'll do that same thing to get your normal and tangent lines. I hope that this video was helpful. I'll see you in class.